Hi, today we'll be looking at the ways of breaking covalent bond. Now, for chemical reactions to occur, there must be formation and breakage of bonds. And in chemistry, bond breakage is actually called bond fission. And this is particularly important in organic chemistry because it involves the breakage and formation of new bonds. Now, there are two ways bonds can be broken in covalent bonds. The first one is actually called homolytic fission, while the second one is actually called heterolytic fission. Now, let's look at homolytic fission. Now, in homolytic fission, each of the bonded atoms take one of the electron pair. Let me give you that. Look at it. A bonded to B. Now remember that each bond stands for 2 electrons, so I can represent it as A. Now we have this, and then we have another electron bonded to what? To B. Now in homolytic fission, like I said, each of the bonded atoms take 1 electron. So what happens is that this, and then now when you are showing homolytic fission, use a curly arrow that has half an arrowhead. Now, and this will give us something like this: A with 1 electron plus B. Now, what do we have here? We actually have what is called free radicals. So it therefore means that homolytic fission leads to the formation of free radicals. Both of them are actually free radicals. Now, there are certain conditions for this thing to actually happen. However, homolytic fission is easily seen in non-polar compounds. Yes, non-polar organic compounds easily undergo homolytic fission, and that's why you have something like carbon to carbon or a carbon to hydrogen, not really polar organic compound. Now, what are the conditions needed for homolytic fission to occur? The favorable condition number 1, the presence of a non-polar solvent. The presence of a non-polar solvent. An example of that is hexane. Another important thing is high temperature. High temperature can really drive this reaction. Now, also you need an initiator, something that initiates the homolytic fission. Another important condition that drives homolytic fission is actually the presence of light, and that could be from sunlight or ultraviolet radiation or UV light. Now, these are the conditions needed for homolytic fission to take place. And remember, homolytic fission leads to the formation of free radicals. Another important condition, which is the last one, is the presence of inductive effect or resonance. Now, to stabilize the system. The reason for that is it helps to stabilize what? The system. So I've mentioned the conditions. The first one is presence of a non-polar solvent. Second one is high temperature. Then you need something that initiates that homolytic fission. And then most of the times they're peroxides. Then sunlight or UV light. The presence of inductive effect or resonance effect to stabilize the system. Once you have that, then homolytic fission can actually occur, but it's more prevalent in non-polar organic compounds. Now, the next one is actually heterolytic fission, and let's look at it. Now in electrolytic fission, the electron pair between the atoms, let's use A and B again. Now A and B, and then you have this. Now in electrolytic fission, both of the shared pair actually goes to only one of the bonded atoms, meaning you're going to be having something like this. Now remember that both electrons that make up the covalent bond is actually taken by one of the bonded atoms, and this will give us something like this: A plus B minus. Now actually, what is this giving us? This is giving us a cation and then an anion. Now in that case, especially in organic chemistry, if it has to do with carbon, it's called a carbocation or carbonium ion, and then the anion is called a carbanion. Now let's see that. Let's see an example. Imagine that you have, this is methyl chloride. Now, and this is very particular in polar, it's particular in polar compounds. Now what happens is that the shared electron is actually taken by chlorine, and then you're having this plus Cl minus. Now this is called a carbocation or a carbonium ion, while the negative is actually called a carbanion. Now this is actually, like I've said, is prevalent more in polar compounds. Remember that in electrolytic fission, just one of the atoms takes the shared pair, and they're giving us a carbocation and a carbanion. Now, what are some of the conditions that actually favor or drive electrolytic fission? The first one is, now let's talk about the conditions. Now, the first condition that drives what is called electrolytic fission is the presence of a polar solvent. Example, ethanol. And then the second one is actually the presence of inductive effect or resonance, and you should know the reason for that. It is so that it can stabilize the system. I've told you electrolytic fission is more prevalent in polar compounds,